Hey guys, welcome back. Our next speaker, Eternal Paradox, is a lovely person, and he's actually one of our community members. So I'm going to go ahead and pass it over to him now to present his presentation.
All right, well, my name's Eternal Paradox, and today we're going to talk about capabilities, that one vulnerability vector we don't realize exists. So who am I? Well, I'm a cybersecurity enthusiast. I've always loved things like hacking, cybersecurity, cryptography. It's basically a never-ending puzzle solving. What are my hobbies? Again, I love hacking, I love going to a gym, and I love watching anime. My recent accomplishments have been, well, my most proudest accomplishments have been VHL and my OSCP. So why am I here? Why am I presenting all of you this? Well, on my OSCP, in order to study, I had to learn something called capabilities. And in one of the labs, you had to do privilege escalation. But the cool thing of this privilege escalation was that it was supposed to be via kernel exploitation. Now, that's another technique that I'm not going to discuss today. But the cool thing is that I noticed that there were capabilities running on that lab, and I was able to pawn it in a different way. So hopefully, after this presentation, you guys can do the same. So this is more or less the index of all the points that we're going to be talking about. We're going to specify what are capabilities. We're going to explain what are an XCV, what are sets, what's the usage, examples. Then we're going to go into the practical stuff, so actually scenarios where we're actually exploiting privilege escalation. We're going to go to questions and finally to the end. All right, so what are capabilities? Well, I could present you by you reading all this manual, but it gets really hefty. So let me explain it in a better way. Capabilities are attributes that we give a binary in order to bypass some things. What does that mean? All right, so we know that Linux works with different privileges. For example, if I was eternal, I cannot do things that root can or the administrator can. But here's the catch. Say, for example, you want to read itsy shadow, right? Itsy shadow is basically a file where all the passwords contained, all the hashes are contained. But what happens? When you run cat itsy shadow as eternal, it's going to give me permission denied because I don't have the sufficient user privilege. So instead, I need to become root. But with capabilities, if we apply, for example, a capability to cat that would allow to bypass the reading permissions, then even though I'm eternal, I would still be able to read root level files. All right, so two new concepts that we need to understand before we really dive deep into capabilities. What is execv? Well, execv, or also named as execute program, it's essentially a little executable which we're going to run, and its main purpose is to run a specific program where we set up as an argument its path name. Why is this important? Because at least on C, before you can run something, it's not like bash where you can just say bash.sh. You need to actually compile something and then run it. For example, on my left, I did a really quick script. I said include std library, initiate the function execv, use the function main, and then run execv with /bin/sh. Now, don't worry about the zeros. This is just specifying what arguments I need to run on the shell, but because it's just one command, it's all zeros. Then on my left, I actually compile execv. And as you can see, when compiled, it runs as a shell. So why was this part important? Well, the reason behind it is because capabilities use execv kind of behavior, meaning that when they run, they're going to run always as suid of root. So that means that, well, SUID or the user ID is basically what identifies to you as in Linux privilege. For example, Eternal might have a UID of 54, but root will always have a UID of 0, and capabilities will always run in UID of 0. Right. So what are sets? Now, we talked about capabilities, but the problem with capabilities is that they're really dangerous in its own nature. So there needs to be a way of controlling them, and that's where sets come into play. There's two different types, as we can distinguish here. There's for threads and there's for files. Now, each one of them have different type of sets. So in terms of files, we have permitted, inheritable, effective, bounding, and ambient. And in thread, we have every single one of them except bounding and ambient. So what are they? Well, permitted is basically, hey, do I have permission to use this capability? And if so, what is the best way that I can run it? Inheritable is, hey, I noticed that my sub-process is also running on the process. That means that because that process is part of the sub-process, it will inherit that capability. Effective means All right, cool. This capability works, but how many capabilities can I map into a different binary? Bounding is a combination of two. For example, permitted and effective, inheritable and permitted. And ambient, which is really cool, it's a later version. And what it does, it dynamically checks what is the best capability for that binary. Now, it is really important to understand that usually binaries, because of the way they're made, they need to be, there has to be a combo, like a bounding combo of effective and permitted, which we will see later. And on my left, this is a bit too, this is advanced to the scope, but I just want to show you how it works. Essentially, it's mapping every single set with other sets, like combination of both. We're using OR and logic gates. And it's always doing it before and after the exec-v. That's like the only important thing that you guys need to know. Also, really important, I always leave reference just in case you guys want to continue with me. All right. So usage, we understand better how capabilities work, but how do we actually use them? All right, so if you see on my top left, I do a little copy, which cat modified. What does this mean? Well, first I use a $sign to say that this is a command running. So I'm going to say, hey, I want to know the path of cat. Then I'm going to copy this path and I'm going to modify it to cat modified. Then I'm going to use getCap cat modified. So what is getCap? Well, getCap stands for get capabilities. And it's the tool that's going to let you show what capabilities are already put or given to that binary. So right now, because we didn't add any capability, we get no output. So how do we actually set a capability? Well, we use setCap. And this is interesting. So we say setCap, Capsid Uid plus EP, cat modified. So what is Capsid Uid? We'll see a bit later. But important part, the plus means, hey, I'm going to append a set, and EP means effective and permitted. And usually that's what you're going to see. You're always going to see a capability plus effective and permitted. So now when we do getCap again, we see that this cat modified now has the attribute of Capsid Uid. All right, let's say I want to remove it. Well, it's as simple as just saying setCap minus R on cat modified. So now when I getCap again, there's nothing. All right, so what is my thing on the top left? No, top right. So that's capsh print. And what does it do? Well, this is a really cool tool. Essentially, it kind of debugs your capabilities for you, and it checks your privilege mode. For example, if it's root, it's going to tell you, okay, these are all the capabilities that I'm allowed to use. If you're eternal, oh, you might not be able to use this one. And another thing that is pretty interesting, it also tells you what sets you have currently in your entire system. Now, this is a really cool trick, which is on my bottom. And it's essentially, we know that getCap gets a capability, but the problem is that it only has one path. So like if I say getCap cat modified, it will only get one. But if you do minus R, and that doesn't stand for remove, but actually for recursive. So what it's going to do, it's going to recursively check for every single part of your system, and it's going to try and get all the capabilities. Now, why did I do this weird two-triangle dev null? What is this? Well, we need to understand what two-triangle is. That's standard error. And that's things like, hey, permission is denied. You're not allowed to be here. By redirecting this to dev null, meaning I'm redirecting this to nothing. Therefore, I'm not going to see any errors, kind of. So it's a way of bypassing all this permission denied, permission denied, permission denied when I run the command. All right. So examples. Remember this? This was the Capsid Uid plus EP. So what is all this? Okay, well, this is the actual capabilities. There's many more, which you can see on the reference page later if you want. But these are, for me, the most important ones, and for me, the most fun, in a sense. So Capsid Uid. Capsid Uid is a capability that permits you to modify or bypass set UID permissions. What does this mean? Well, we talked before about UID, right? We talked about how eternal may not have the same UID as root. But set UID is let's say a function, I guess that's the best way of saying it, that lets you change that UID. But of course, I myself, eternal, cannot do something like set UID to root because I don't have permissions. I'm not an administrator. Unless I use a binary, right, that then would have this capability, which we will see later. All right, so that's the first one. Second one, cat-tac read search, also short for domain access control read search bypass. So this capability works the following way. As I said before, we cannot read cat itsy shadow as root. But if we were to put, for example, a capability such as cat-tac read search on cat, we would be able to bypass read permissions or even write permissions. Therefore, the exact moment that we're running cat, well, this modified cat, sorry, then we will be able to actually read each shadow with low privilege user. And finally, capf owner. This is one of my favorites. Basically bypasses permissions of changing owners. So what is an owner? Well, when I run a file, that file, well, when I make a file, that file is the one that has my context. For example, if I make a hello.txt, Eternal is going to be the owner of that file. If root makes a root.txt, root is going to be the owner of that file. Now, we can use things like chown or chmod to modify permissions or ownership of a file. But here's the cool thing. Again, Eternal cannot use chmod or chowner to root because I'm not root. But let's say I, for example, made chown or chmod with the capability of capphoner, then I might be able to bypass that. All right. So this is an important part before we start with the labs. Assumptions before scenarios. So number one, we assume that in every single scenario, we're going to use getCap to see what capabilities a binary has. Let me expand on this. This is just a lab that I'm doing, right? So I'm setting everything up, but we need to understand that we need to look this at in a pen test point of view, meaning that everything is going to be completely, well, it's going to be an entire system. You're going to be in a system where you don't know any single binary at all. So you need to run getCap to make sure to see what capabilities does it run. Second, we assume that the scenarios work because root has accidentally written capabilities to binaries it wasn't supposed to. All right, so you will notice on my labs that I always say something like cat modified, chmod modified, tar modified. The reason is because I don't say because I put the modified is because if I were to put the original one, then I would basically fuck up my entire system. So yeah, but let's assume that they're all original. Third, in every scenario, on my left terminal, we find the user who is root, meaning it has low privileges. And on my right terminal, we find the low privilege user who has low level of privileges. Now, number four, we assume that despite in the demos, it's always binary capped is what I was explaining. This is done to not actually overwrite the original binaries. We can actually make them seem like they were the original ones. All right, so everything is good. We can now start. So scenario one, Python. When we think of Python, we think of coding, right? I think of, oh yeah, I'm just gonna make a Python script. But Python is really cool. And the reason behind this is because there's two ways of working. You have terminal and context. So you will see now. First, I do a little ID to show you guys my privileges. On the left, we have root with UID 0. And on my right, we have low priv with UID 1003. All right. So bet you guys didn't know how to do this. So there's an OS system library that we can run in context of Python, which will let us invoke a bash shell. Now, I'm going to pause this to explain this in a minute. Whoops. All right, yeah. So import OS. That's the OS module which lets you bring system level functions. Then os.setUID0 will basically set your UID to 0, meaning that low priv will not be anymore 1003, he will be root. But here's the problem. We cannot do that. We are not allowed to do that, as a matter of fact. So when we run bin bash, oops, typo there, my bad. Operation not permitted. So before I hit play, I want you guys to think, what capability would root fuck up in order to be able to bypass this thing? Remember, we have Capsid Uid, which lets you change setuid permissions. We have captag read search, which lets you bypass read permissions. And we have capf owner, which lets you change ownership. Well, little hint here, I did os.setUID 0. So let's say, oh, root modified Python 3, and now it's Python 3 modified. And now we're going to set the cap of what? Capsid Uid. We do that. We run getCap always to make sure that it's correct. All right, let's set it up. We run the command again. And when we do so, because we've bypassed setUID permissions, bingo, we are root. Now, this is a really important concept because you will notice that my GID and my groups are not 0. In fact, they're low priv. They're still low priv. What does this mean? Well, setUID only changes UID. Now, group ID is basically what group I'm allowed to in the files. And groups is basically what groups are there. But the most important part is your UID. That's what basically is going to dictate in what context you can run things. All right, awesome. So scenario 2, Ruby. Now I made basically, I'm going to show you guys 3 examples of the same capability. So you see different ways of exploiting it. But yeah, I really had a lot of fun doing this because it's just trying to figure out your imagination to do everything and then try and find the best way to exploit something. So we can use process in order to invoke a system with setuid and then run an sh. But here's the problem. When we run the sh shell, we get operation not permitted. So what do? Same process. We copy the binary Ruby file, right? We assume that root has misconfigured this and that he has let by accident a Ruby cap with Capsid Uid on it. So now when we run it again, skip a bit. There we go, root. Same thing. All right, and finally, for the same one, PHP. Now, don't you find really cool how different programming languages let you invoke shells just like that? I mean, imagine the power that we would have if we discovered capabilities of this type of level. All right, so here I'm just going to invoke a normal shell. And then after this, I'm going to ask an interesting question for you guys to think. So we run system command, ID. Oh, we ran the shell worked, but we're still low priv. So same process. We copy the binary. We append Capsid Uid as a matter of fact, always plus CP because we want effective unpermitted. We do a get cap always to check what capability it has, and we run it. Bingo. All right, so here comes a question for you guys to think. Now, let's say that instead of me running php-r POSIX setuid system cmd, I only did php-r system cmd. Would I get low priv or would I get root? I'm going to give 2 minutes. All right, well, actually, you will not get root. And the reason behind it is because the important part here is that I'm always doing setuid 0 before it. It's basically bypassing the checks of setuid. This is why it works. This is why the capability in itself is called setuid. If I were to only run the bash script, it would say, hey, what the heck? You're not allowed to do this. All right. Next one, cat. I did a little foreshadowing on my start of the presentation, so you guys should know what this is going to be about. So we try to read cat shadow, but we're not allowed to, as a matter of fact. So again, what capability should we be able to use once root misconfigures modified cat? Let's think. We want to have read permissions bypassed, right? So we want cap tag read search. So plus CP on it. Do a get cap. Run it again. And there we go. Now, interesting story in this. Some of this, I got them from Get the Fuck Out Bins, which is basically a really cool website that I'll show later on my resource page, where you can see all the capabilities. But this one, for example, was a 0-day, quote unquote, that I made. And the reason behind it is because it's really out of the box thinking. So you need to think, okay, what does this binary do? What capabilities can I use? And then how can I exploit it? Yeah. All right, so scenario 5, tar. Oops, I'm gonna add this. Okay. What is tar? Well, tar is kind of like a zip file where you can like tar things or untar things. And there's a really cool trick, which is you can try and, well, this is just me in order to make my life easier. I copy its shadow on shadow file. So then we have it here. So before I'm gonna pause this real quick. So see the root. The first root is basically my ownership, and then the other root is groups. Now this is telling me, hey, I am low priv, therefore I cannot read shadow file because I'm not the owner, nor I have any permissions. So I'm going to try and tar this, right? There's a little cool exploit in a sense, which is that if you try to tar Etsy shadow, you might be able to grab shadow as the other user, but we will see, as imagined, that will still have permission denied. As a matter of fact, it says permission denied. So what can we use here? Because we're technically not reading, right? We're not actually reading. Tar is just compressing and uncompressing. Well, before I actually show you guys the solution, before I show you guys actually the solution, I want to make you think something. How tar works is basically it writes things on the file while it's being tarred or untarred. So the only thing that can bypass written permissions is, in fact, cap-read search. So when we get to get cap and we notice that it has cap-read search on it, when we do it again by doing XVF on it, yep, we see that now it doesn't say permission denied, as a matter of fact, but it says Etsy shadow. What does this mean? This means that now, see this shadow file.tar? It was able to be tarred, but look at the interesting part of here. The shadow file.tar does not contain any more root. It contains low-proof and low-proof. So now once we untar this, and this is for me, like, to be fair, I love this. When we untar this by using XVF, we will notice that this new Etsy shadow directory is not root anymore. It's me. Therefore, I can just read it. And I find that honestly amazing. Yeah, capabilities are really cool, man. All right, so scenario 6, Chmod. Now, we've talked about many capabilities except one, cap owner. So let's look at this. This is a bit CTF-y, right? Let's say that the root decides to do something as, oh, only root can see this file. Right? We append it to root.txt, and just for measures, we do chmod 000, which means, hey, I don't want write, written, or executing permissions of nobody except root. Therefore, root is going to try. Of course, it can read it because it's the owner, but I won't be able to, right? So what can I do? Well, I could use cat again, set read search, and probably bypass it again. But I want to do it a different way. So Chmod will basically want to change permissions so you can read everything. 777 means, hey, I'm going to be able to read, execute. I want to do everything with this file. But we can't because we're not root. So what could we use? Well, we can use, as you might imagine, fowner. Because we're basically bypassing this owner change privilege. So once we run it again, you will notice that when we chmod 77 as the modified one, boom, first of all, it didn't give us permission denied. And second of all, even though it's still owned by root, we have all permissions. So the first RWX means, hey, the owner can read, write, execute. The second one is others can read, write, execute. And the third one is groups can read, write, execute. Because everything is read, write, execute, I myself now can actually read the file. Yeah, this is not super interesting because it's just a file, but let's say, for example, private SSH keys, your HC shadow file. There's so many different ways and creative ways you can exploit all this. All right, so this is just a little question that I made to myself. So I understood that capabilities run as root, right? But I was asking myself, hold up a minute, what if I make a sudoer? A sudoer is basically a person who can run sudo privileges, and it's equivalent of an administrator. So I was like, okay, what happens if I try to exploit a capability with sudo, right? With sudoers? Well, interestingly enough, I can't. And the reason behind it, after checking and learning, is that capabilities will only run in context of root or UID of 0. Therefore, I tried doing things here, as you can see, as creating a file, setting a file, even modifying a file of that specific user, but I'll never be able to. So what is like the conclusion of this sudo experiment? Basically that you will never be able to privisk laterally. You will only be able to privisk to root. All right, so this is my conclusion. This is what, guys, I want you to understand. I want you to think. First, what does that binary do? Second, what can you do with that binary? Third, what capabilities you can attend to that binary? And fourth, use all those previous steps to exploit the shit out of it and have fun, to be fair. All right, so resources. These are all the resources and basically everything that have helped. I also want to give credit to TJ Null, who was one of my mentors, and man, he's the best. Like, super cool guy, community at offensive security. Offensive security is amazing. They've taught me a lot. And yeah, that's all. Questions?
We have a few.
All right, awesome. I'm here
Right.
for it then.
So JFunction asked us a pretty interesting question. So if you type unshare-r, you can impersonate roots similar to what you just did with Ruby or PHP or Python. The ID will be 0. Is this doing the same process, or is it doing something magical and rad?
No, it is actually doing the same process. So what it's doing behind it is that it's set UIDing to 0 before it runs. Therefore, it's running as the context of root instead of the user that it was holding at.
Alrighty. And then the second question is, how often are capabilities used in professional pen testing / everyday hacking?
All right, that is a really good question. So I myself, I'm not really sure, but I think that this is more of a kind of opportunity-wise type of attack. So like if you see a binary that has this type of capability because root has misconfigured it, go ahead and exploit the heck out of it.
Alrighty, awesome.
Awesome. Is it in your experience something that can happen by accident, or is it something that is a human error, basically?
It has happened to me twice. And I myself modified a capability by accident, so I'm also a victim of it.
Okay, so basically this is a great warning to all the sysadmins out there.
Yes. Run getcap and make sure that all capabilities work. Another cool thing for mitigating it is you can grab another system, another computer, and check all the binaries capabilities and see which one doesn't, like fit in.
Awesome.
Yeah, thank you so much for that. That was really fantastic, really engaging presentation. So
Not even worries, I love doing this. I hope everyone has learned a lot, and next time when they see capabilities, they can exploit them and get elevated access.
Thank you so much.
Thanks for being here.